I picked a cone problem to show related rates. My students always have questions on these cone problems. They are harder because they have two variables, r and h, in their equations, and the problem will only tell you about one of the variables, and then it's up to you to find out the information about the other variable. And we're going to use proportions to do this, and that's what you always do with cones, is you use proportions to find the missing information. So the first step is to draw the cone. It's upside down. So we draw this, and we're going to label on the cone any numbers that are not changing. So it said the height of the tank is 9, so that we can label 9, and the radius of the tank is 6, so we can label that. And then there's water filling the tank, so we can just show the water in there. They did say that the height of the water is 3 centimeters, but that's a number that's going to be changing, so we're not going to label a 3 on the picture. What we could do instead is just write an h, and then the radius we can label with r. So that's our picture. Now the next step is to make a list of all of the numbers that we know that they gave us. We don't have to write down the 9 and the 6 again because those are labeled right on our picture. So they did say that water is filling the cone at a rate of 4 centimeters cubed per second. So that value is dV dt, the change of volume with respect to time. That's 4. We know that's volume because centimeters cubed is the units for volume. Then they also said that the height of the water is 3 centimeters. And we labeled that h, so we can say h equals 3. And then finally they said find the rate at which the radius of the water is changing. So dr dt is what we are trying to solve for. So we can just say that equals question mark. Now after you make a list of everything you know and also of what you're solving for, you want to write down the main equation that relates all of these variables, which is volume equals 1/3 pi r squared h, the volume of a cone. Now see, here is what makes it harder, is that volume has both r and h in it. And since we're going to be solving for dr dt, it would be much better if we only had r in the equation. So one way to get rid of the h is to notice that in the cone, you're going to have a proportion that you can set up because 6 is to 9 as r is to h. So I can jot down that proportion. 6 is to 9 equals r over h. And since I want to take the h out of my volume, I'm going to get the h alone in this equation. So first I cross multiply. 6h equals 9r. And then I get h completely alone. So I have h equals 3r over 2. I just reduced that. And I'm going to take this expression for h and substitute it into the h up here. So now my volume will equal 1/3 pi r squared times 3r over 2, because now my volume only has r's in it. And I'll just simplify that a little bit, and that's going to become 1/2 pi r to the third. So there's my volume. Now the next step is always to take the derivative of your equation. So that's going to give me dV dt equals 3/2 pi r squared dr dt. And then we start plugging in any numbers that they gave us. So we know that dV dt was 4. So 4 equals 3/2 pi. We don't know the r yet, but we do need to go back and figure out what that was. And then dr dt we don't know, but that's fine because that's what we're solving for. Now the way to find r is to also go back to this proportion that we used before, this one, and we know that 6 over 9 equals, and at this instant, we don't know the r yet, but we know that the height of the water was 3. So we can say that and use that to solve for r. So if I cross multiply, I get 18 equals 9r. So that means that r equals 2. So I'll go back over to here and just plug in that 2. And we've almost got our answer. So this is 2 squared now times dr dt. So now if I finish solving, this is going to be 4 equals 3 halves. This will be 3 halves times 4, which equals 6 altogether. So 6 pi dr dt. And just divide by 6 pi on both sides. And so let's go over here. So we have 2 over 3 pi equals dr dt. And then the very last step is the units. You need the units in your answer. Now this was the rate at which the radius was changing. Radius is measured in centimeters. So here's our final answer. It would be 2 over 3 pi centimeters per second. And that's our final answer. So just keep in mind, with any problem with a cone, you're most likely going to be setting up a proportion with the radius and the height. And that will get you where you need to be to find your final answer.